Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust language. My name is Luciano, and today I'm joined by.
Eugene?
E Roberto.
So, what are we doing today is basically trying to learn Rust while we solve the challenges from Advent of Code. If you don't know anything about Advent of Code, it's basically this website here that you see down there. And it's basically something that gets published every year, 24 days before Christmas. Every day you get a different challenge. It builds up an entire story, and you can go to the next day by solving the challenge using code. And it's interesting because you can use pretty much any programming language, and we decided to use that as a good excuse to keep practicing Rust and possibly learn new things. Keep in mind that we are still total noobs with Rust, so we're going to be doing a lot of mistakes. So feel free to tell us in the chat what do you think, if you have better solutions, if you have ideas that you want us to try. So let's make this more interactive if possible. And we have our solutions in this repository, so you can also feel free to contribute, send us PRs, comments, whatever. And we have already actually solved some of the exercises from last year, 2021, and today we are going to continue looking at the exercise for day 4.
Yep. So let me know when you share
So
the
I'm
screen.
ready to share the screen. Yes, sorry. There you go.
Sorry, I was ready to take over, but I didn't specify. Yeah, so we'll have to look at the README in GitHub for this one, because we needed some numbers marked, and it's difficult to do that in a text editor. So we have a pull request open for this, and we're going to look at the question first, the challenge itself, and then we're going to look at our solution, maybe try to optimize some things, and then merge the PR in once we're done. So for day 4, it's imaginatively named Giant Squid. The premise is that there's a squid that maybe wants to play bingo with us. We're in a submarine, and the submarine has bingo subsystem capabilities. So, pretty usual stuff for a submarine.
I am surprised it's not like a free cell simulator.
Yeah, it could be. And we could do that for like the next generation submarines. So essentially, what we get is a list of numbers which are going to be called out as the bingo numbers. Actually, maybe I should start by explaining how bingo works. In bingo, you get a card usually, which is like a grid, usually a square grid, I think, and you get like a bunch of numbers in each of the column on each of the row. There are different grids that you can get, and these numbers are called out by whoever is running the bingo itself. And whenever you get a number, you mark it on your board, and you mark it as like, this thing was called out. And whenever you get a horizontal or a vertical line marked, your board wins, and you win the bingo. The goal for the first part of this exercise, we actually have an example here of, so the first 5 numbers are drawn, which are 7, 4, 9, 5, and 11. And you can see now we have the 7, which is in bold. I'm sure you can see that really well on the screen sharing.
Yeah, slightly bolder, but
Well,
Yeah.
they're marked. Let's say they're marked. So yeah, basically these numbers are marked, and then more numbers are called out, and more numbers are marked, and so on. So at the end of it, the goal of the first part of this exercise is to find out which board will win first. So go through that list of numbers and find out which board will be the first one to win. I'm gonna
so
stop
pretty
sharing.
much we need to simulate the entire game until one of the boards wins, right?
Exactly. I'm gonna stop sharing my screen, and I'll start sharing the text editor instead, so we can
Yes.
actually have a look at
I
the
think we forgot to
codes.
mention one thing that might become more important as we look through the code, which is the question is
Oh yeah.
which board wins first, but then there is an algorithm to calculate the score for that board, and that's actually the answer we need to give. And if I remember correctly, the algorithm is that we need to look at all the numbers in the winning board that were not marked, so that were not extracted yet, sum all of them, and then multiply the result for the latest number that was extracted when that board won.
Correct.
So we will need to implement this little formula as well to be able to give an answer to the puzzle.
Yeah, exactly. You're right. Sorry, I should have mentioned that. Yeah, sum all the unused numbers and multiply them by the last number drawn, which was like the winning number essentially. So yeah, have you shared the screen? The editor you have. Perfect. Okay, so the first thing we did, and when I say we, I mean Luciano, but I'll take full credit for work I didn't do.
Especially for the mistakes, yeah.
Yeah, exactly.
Are you studying to become a manager?
Me, yeah, exactly. That's my long-term goal.
You are manager in training.
Exactly. Claim other people's success, gloat, shine. Right. So the first thing Luciano did was to define a struct for a board which contains rows and columns. The reason for this is because we care about whether a row was completed or a column was completed. And the way this works is whenever you mark a number, you remove it from the hash set, both the rows and the column set. And whenever a set is empty, it means that, well, you have a winner, basically. It's probably one of the easiest ways to keep track of this. It's one of the easiest ways and the least expensive ways to check. Because you don't have to go through the entire thing, you just check if the set is empty. So to that end, we have a struct, we have an implementation for it, where we have this mark function, which basically also checks if the current board is a winner. And what it does is it goes through every row, and if the number exists in the row, it will remove it, and then it checks if the row is empty, and then it tells you that it's a winner, and it returns whether this was a winning board or not. There's
so
also
this is pretty much the function we're going to have to call to simulate every single turn of the game. So every new number extracted, we need to go through every single board, call this function to make sure that the board is updated with the number extracted.
Exactly. Apologies. Yeah. And then the board also has a score method, which calculates the score for itself, and it receives the final number from the outside. This is basically that little algorithm that Luciano mentioned earlier. Because we keep the rows and the columns separately, we only need to go through the rows, otherwise we'd get double the results. So we just go through each value in every row, we add them up, and then we multiply them by the final number, and that's our answer. There's also a from string implementation here, which, oh, by the way, on this rows and columns thing, it might be cool to deduplicate this code, because essentially those two for loops doing the same thing.
Yeah.
Just one of them is going over a row, one of them is going over a column. We could do like maybe a function, like either keep it on board.
Yeah,
I don't know.
could.
Let's go through the entire thing first, and then we can look at improvements. Does that make sense?
Yeah, there is also another one I'm going to show now that if the score method is called at the end, can consume the board, avoiding that asterisk thing. At that point, we can probably even use fold or sum or something like that. Yeah. But this is another good suggestion we should try to explore at the end.
Can you show me the input file just to understand what we have to
Absolutely.
deal with? Okay.
So this is basically the line of numbers which are going to be called in sequence. And then below, we have all the boards. They're all 5 by 5. And there's, well, as you can imagine, a bunch of them.
Yeah, probably hundreds.
600 lines divided by 6, let's say.
Yeah.
It's not that
100,
many.
100 boards.
100 boards, yeah.
Plus one line for the input at the top.
Yeah. It's 99 boards then, basically.
Well,
no, it's
100 because it was last line was a 601. So.
Oh yeah, it is 601. Right, you are. Yeah, it's 100 boards. So, a good number. Yeah, so this is how the input looks. Basically, part 1 starts by splitting here, so you get the sequence, and separately you get all the boards. I can actually show you that if we go to part 1. Yeah, there you go. It's actually splitting by a double new line and unwrapping, because that's how we roll. And you have the sequence, which we then split by comma, so we get all the numbers, and then we generate the boards from string after we split them further down. And this is where the parse thing comes in, because there's basically calling this from string bit, which is something we've done like 50,000 times already, so I don't think I need to go into it too
there are
much.
here a couple of things that might be interesting,
Mm-hmm.
and maybe we can figure out if there are better ways of doing this. The first one is that here we needed to do this hashtag default 5 times. There is a shorter syntax that you can say hashtag column default, then semicolon 5, like pretty much what we do in line 43. We can do it also on the right side. But for that to work, I think it needs to implement clone. And I'm not sure that hash set was implementing clone. So we might try to do that and see what happens. I think that was the reason why I decided to be lazy and repeat this 5 times.
Yeah, fair enough. I do agree it doesn't look pretty to have the same thing 10 times
And
over.
you can also use default, which, as Thomas suggests, is pretty much the same thing. When you know the type, default will know that you want to call hash set default pretty much.
Yeah.
And it's probably more idiomatic to do it that way.
Type inference rocks.
And you can replace
hello, Berduda. Welcome to the channel.
Hello.
Can you replace all the array on the right side of the equal sign with a default something or not?
Default of all of it? We can try it, actually. I'm not sure.
So a default can create an array. The question is just this one. An array is a static in-memory structure that is not really created at runtime.
We can just try that. Try to replace the array until line 49 with just default, like here.
Wait, sorry, typing.
It's complaining about it?
It's not complaining.
Let's
see if it
your
runs.
Rust analyzer is
broken.
Well, it seems to be just fine.
Cool. Okay, that might work, and that's way easier and better solution.
Let me try to do it for both of them, and let me try to run the test. Right?
Yeah, even just part 1.
Wait.
If it
part 1. We'll see. Let's see. This is the first time I'm running it, so it's going to take a little bit longer. Nope, it worked.
Perfect. That's brilliant.
Beautiful.
Thank you, Tommaso.
Okay, so Tommaso is saying, array implements default if the type implements default.
That's nice.
Likewise, Berduda is saying that, pretty much he's using the primitives, otherwise that implement default.
Perfect.
Cool. So we are learning new things. This is working.
Yeah, this is nice. I like it.
The other cool thing I wanted to mention is that something I discovered with this exercise that I didn't know before. In line 47, we have that split. We generally split by either a character or a sequence of characters, and we use either just regular split or split once. And I discovered that there is split white space, which it's interesting here because sometimes you have one space, sometimes you have two. So this one will take care of just normalizing all the sequence of spaces and split once there.
So if there is 2 spaces, it will not create an empty element in the middle of the split.
Yeah.
Is it doing this basically as a regular expression?
Probably it's doing something similar. I don't think it's using regular expressions because otherwise you'll need to import the crate for regular expressions.
Yeah, and it's slow to implement the regular expression for.
It was more in is it doing what that would do rather than
Yeah, I think so. It's very similar idea.
Okay.
So that should be easy enough for us to understand Yeah, we basically do a double loop there to fill rows and columns for every
Mm-hmm.
little number we find in the board. And funny enough, that split white space, I think, yeah, we do it for every line. So we split by line
Yeah.
and then every line by white space.
Yep. Because the input is separated by white space, but they're all arranged basically. Sometimes
Yeah,
with
they
two
are
spaces.
aligned, so you might have double spaces.
It's not 0, 7, it's space
Exactly.
7. Yeah.
And you are, let's see,
Sorry.
you are parsing it to
Yeah.
U8. Okay.
And then it's inserted in the correct hash set for the row and for the column.
Yeah, stupid question. If they were aligned with zeros, for example, some languages, if a number starts with 0, they understand this as an octal. What is default behavior for Rust?
One way to find out, isn't it? Isn't there?
Oh yeah, if this explodes.
Well, if he's getting it as a 7, is fine. It's working the same way.
Yeah, you should put a 9 or something like that.
Yeah, 0, 9. But then you will break the test.
We need to find a 9.
0, 9. Yeah.
No,
so let me just find a 9.
Alone.
Yeah. There we go.
Yeah, 0, 9 is not a valid octal, but it's valid base 10.
Yeah, it needs to be interpreted as a U8 9, basically.
Yeah. So we're not actually. It's probably gonna fail on parsing, right?
Yes. Yeah.
Although we are telling it to parse it as a U8, so.
No, but yes, but the start point is a string that represents a base 10, or if it starts with 0, is a base 8. How is Rust behaving? So let's try. If it no, it's an integer for him. Perfect. So
that's good.
Like JavaScript. Okay, it's not the best language to take as example, but when you shape your casting, JavaScript is not probably the best
very,
one.
very predictable.
Yeah.
Yeah.
Not ideal, but hey, in this case, it saves you some trouble.
Let's sum this dog with this quantum. What do you have? A platypus. It's reasonable.
Exactly. Okay, so parsing works just fine, inserting works just fine, and it returns this. It returns an OK of a new board with the rows and the columns. So after that, because we haven't actually gone through how this thing works, it goes through every number in the sequence. It iterates through every board that we have, and it checks if the number made it a winning board. Then it returns the winning board's result of the scoring with the number that was called.
So Mark is removing the number from the sets that are in that board and returning a boolean that tells us if with that number the board won. So basically one of the set become empty.
Yeah, and that's the reason why we use iter mute, because board mark needs to mutate the board, so it needs a mutable reference.
Yeah. That's fair enough. And we return the board score pretty easy. We did say this all looks okay, as in I don't think there's much improvement to be done here.
But we can say where there are the two loops, we can make only one loop on two different variables.
At the very top,
to the line in the mark function.
Okay. Yeah, I know this one. Yeah, I agree. This is what we said we're gonna do. Yeah.
And here I have a question. Can you write something like this? Try this between line 11 and line 12.
Try this being something you pasted somewhere, or
no, I'm
okay, sure.
It. If you
please do
agree. For x, the number in, then open the round bracket, and you write row, comma, call.
I think it's
without
it's call. Yeah. Okay.
Call.
Sorry.
Run call. Dot iter. Do we need to dot iter or is not needed?
I
don't know.
Not happy with this.
I think you might need to
Hang
do like
on.
an array with
So
square
these are
brackets.
self.rows.iter mute,
Yeah, the rows iter mute.
self.columns.iter. Oops, utter.
Yeah, sorry.
No bother. No, it's not.
No, but well, is an iterator item? No, what is called?
We have a suggestion here to use a zip, maybe.
Okay.
That could work. I've never used zip in.
But we have to remove from the right guy.
So this thing zip with Zuo. Apologies.
Zuo.
Is this how zip works in?
Is
No.
that a comma or
that's
point?
a comma. Sorry, it's a typo. Okay, this is how zip works. Cool. Okay, it's just unhappy.
Yeah,
So
the
this
problem is
gonna
that
be
here X will give you a tuple.
Yeah,
So
but I can break it into, right? Like row, call, like so.
Yeah, but
But they're still the same.
Yeah, we are at the same point. There is no way of chaining two sets. List. What is this? Those are arrays. Again, yeah, those are arrays of hash set. There are ways of chaining two arrays.
You can probably chain the iterator, yeah.
So how?
For something in.
Try outside the for just to see if that makes sense.
Okay.
Try to do self.rows.ethermute .chain and then parentheses, and you pass self.calls.
Ethermute, yeah.
Self.call. Columns.
No, it's
right.
columns.
And
all of that should be an iterator. So you can do for set, whatever you want to go for item, whatever.
Okay,
yeah,
it
for
seems
item
to be happy. Let's see if it's happy enough with this. So for item in this
all
thing.
of that, yeah.
And now you do item
It's
remove.
a hashtag, yeah.
Yeah, then you copy the body.
Let me just put this here.
Yeah, Tommaso was suggesting that, but we totally ignored him. So sorry.
Okay.
Sorry.
Sorry.
we got there eventually.
So like this, basically.
Yeah,
that looks cooler than we did.
Rust Analyzer is happy, so
let's try to run the
that's
test.
a good start. Yeah, run. Yeah, still passes. Cool. So we got rid of all the duplication, which is lovely.
There is no need of breaking. There is no need of breaking because the mark is called at every loop, and when it returns true, the loop outside of it is returning. So the return is acting like the break.
Yep.
And then that stuff in line 24 can be a fault at this point, being said that score is destroying the board, but we don't care about destroying the board.
Yeah.
At that point.
Yeah.
Can be, we have to sum the set. And when we have all the sums of the set, we have to sum the sums of the set.
Yes.
So basically we need to do self.rows into iter.sum and then multiply that for final num. Right?
Yeah.
Sorry, into iter, you say?
Yeah, that one will give us sets. We have to sum the sets. So what
I don't think it's going to be happy. Because you need to basically call some.
You need to do
you need to map. You need to map, call sum on each of the sets inside, and then call sum on that.
We have to map to convert the set in the sum of the set.
Set. Whoops. Set. Sum. I think this is going to work. Or something like this, essentially, is what we want. Nope, there is no sum for hash set. So we can fold that.
Oh, but you can do set.iter.sum.
Okay. You are correct. and it's
And
why
you
is
have
it
to
not happy?
multiply everything with the final number.
Yeah,
Is
but it's
not
wait.
happy?
I
Sorry,
think there
sorry.
is also that U64 that because our numbers are U8, so we need to
So
sum
let
as
me just get rid of
U64
all the stuff.
Okay, now
But
it's
it's still
complaining about.
unhappy. Why is it unhappy?
because every time we sum, we are summing
Mm-hmm.
U8, so they might overflow. So we need to, before we sum, we need to interpret every single number as U64. I
But
don't know if there is a quick way to do that.
that's
Yeah,
like another map.
there's
This
not
is
a cast everything to U64.
no, because we're calling iter, which gives us an iterator over it, and we're just calling sum.
Can't we map?
Yeah, but if we
before
map, it's like again several loops,
uh,
and it's actually even more loops because presumably sum is also looping. So we're making it worse.
I'm not sure if it's gonna be worse, but I mean, it's not nicer. Worse
No.
from performance, but it's not gonna be nicer from a syntax perspective.
Yeah.
so we have to, or we declare the hash set as hash set of U64, and we don't care.
Yeah.
In the end, if the CPU from hardware level is using a word is fast as using a U8.
Mm.
Also, it can be faster in some conditions because of how the memory is managed in a dynamic refresh
So
memory.
essentially, you're suggesting we store everything as a U64.
Yeah, we store everything as a U64 and we don't care about cast.
Let's see where else we defined U8s.
Everywhere.
Final number can be a U8.
But you can
Here.
Yeah, I suppose the rationale there was that we have 100 boards. Every board has, 25 numbers. So I think there is a little bit of saving if you keep everything
Oh,
U8.
wait. Sorry.
Yeah, that is true, but if you have to
Okay.
get mad with casting between integers type, come on, guys.
So we don't.
Those are
okay.
integers.
It's still not happy though.
There is another U8 there.
There is a
Where? Yeah, the final number. Oh, do we want to parse that as a U64?
Everything
as
will
well?
become a U64, right?
Sure, okay. Can do. Is there any more U8s in our code?
There are two of them.
Okay, now it's all U64s.
Yeah,
But
Tommaso
it's
was saying something. Cannot infer type.
Oh yeah, we need to change into iter for iter.
Yeah.
I think.
This one. I don't think so.
And now cannot infer type for the parameter b declared on the associated function map. Because we are not closing the bracket. No, we are closing the bracket in the right place.
We are.
So sum U64.
Thomas is suggesting this one. Oh yeah, because sum is not. I mean, it will be inferring the type. Okay, so yeah, let's do that. Good suggestion.
And this one also needs to be the same, I guess.
Before the parentheses.
Oh, sorry. Yeah, whoops.
And you need to put angular brackets.
In angular brackets.
Yeah.
I did it 2 seconds ago. Of course, I can't do it a second time.
Cool.
We don't
and
need
now
this anymore.
We don't need the score anymore. Perfect.
means
So you
we
can
don't
even
need
remove
return.
return, and that's cool.
Let's run it and see if it's still happy. Run test. Yeah, it is still happy.
Yeah, let's code.
Let's see if part
cleaner.
2 also works. Yeah, okay, both of them still work. I think we should probably go through this for a second because there is a part 2 to this, which isn't super difficult or super different. Essentially, part 1 is asking us which is the first board to win. Part 2 is asking us which is the last board to win. So, and the scoring is the same. So for part 2, we need to keep simulating and marking the numbers that we get in the sequence until we reach the last board to win. Essentially, all of the boards are valid in this input and all of them can win, which means essentially we're just going to keep going until we run out of boards, and like the last board to finish is the one that we need to score and return that value. So they function in more or less the same way. It's just the part 2 exercises, the part 2 logic is slightly different.
The parsing piece is the same.
Parsing's all the same. It's just the logic has a little bit added
We
to
could
it.
put that parsing in a function that is returning the list of numbers and the list of boards, just to have centralized code or not.
Yeah, we could do that. I think it's more useful to start by going through what it does,
Yeah,
and then we can look at improving. Unless we want to do anything else about part 1.
I think part 1 we optimized the. It's not a lot of code now, and you can follow it quite straightforward or not.
Does anyone in the chat have any ideas on anything else that they might want to do on part 1? Yes, no, maybe?
Yeah, if you do, write it later and we can always come back.
Yeah, we can always come back. Okay, let's go to part 2 and look at essentially up to here, it's pretty much the same thing. We're splitting the input, we're parsing the sequence, then we're parsing the boards into a vector of boards. Then we have this other thing, which is called BB.
For lack of better naming, yeah.
Yep. We could here task 1 name this better.
Should we call it like active boards or something like that?
Yeah, that's actually better. Active boards.
Because it's literally references to all the boards that are still in play.
And this one is just references. So from the memory point of view, it's just a pointer to the board that are passed from.
So at the first turn, that will be 100 items.
Yep.
And you will put then for every item a reference to an actual board.
Yep.
Okay.
But the way it works is basically on every iteration for every number in the sequence, it filters this active boards things. It's running the mark function on it, which is returning a true or a false if it was a winning board or not. If it was a winning board, we filter it out. If it wasn't, we return it back in and it stays for the next iteration. If it's on the last item, as in active boards got to one single item, we keep marking it until it's the winning board, and then we return the score for it.
Question: why a filter map and not just a filter? Because in the end, because we are changing also the board. Why? So you have a list of pointers to the board. You call mark
you can
on
probably
top.
just use filter.
You call mark on top of them, and you change the board. But you got the pointer, and you with this pointer you change the board. You don't change the pointer, and then you give back the pointer. So can we just filter the pointers in the end, or not?
Cannot borrow. Because I think now it has to be.
I think that was the reason why it was a filter map.
Because you want it mutable, and with filter you can't.
Because mark is mutable. Yeah, mark is mutating, sorry.
Yeah, requires a mutable reference.
Otherwise, you have to call mark on top of all the boards, then having another function in the board to tell you if the board is a winning board or not, and filter on top of that boolean.
I think it's actually nicer.
Okay.
Do you remember that we saw that unstable feature called drain?
Yeah.
Yeah, so I think I found somewhere that this is like a current best replacement until drain becomes stable.
Okay.
But especially you can express a mutable function that defines which elements stay and which ones. have to go.
Yeah, but drain will be also able to change, because here the problem is not keeping or not keeping the element. The problem is that we need to have a mutable reference to the element to be able to change it. Drain will be able to have a mutable reference, or will just be
I think so. I'm not entirely
like
sure because
filter.
we were never able to use it
Yeah,
every
because-
time because of the unstable flag. But I think so.
Tommaso has a very good and valid comment there about the filter map. No, the one before it, which is the one I actually agree with. We're doing a filter map and we are changing the data. As in the data itself, as opposed to returning something new.
Yeah, but we need to change the data because we call mark, which will change items.
Yeah. And yeah, the other thing he was saying is that we can dereference the double reference and get a mutable reference. And filter accepts an immutable reference to a mutable reference. Okay. So essentially,
an immutable reference to a mutable. Oh my god, I start to get lost.
yeah,
So does that mean that we need to do like either mute or something like that? I'm not sure I'm following what's the chain of steps before we can actually use
I
filter.
presume so. What I understand, and
there
we'll
it is.
find out. Yeah, exactly. That's what I got as well. To dereference it and then type.
They're returning a true or false and not null.
Yeah, then
or
you
some.
don't even
yeah.
need to return it, to do an if statement. You just
Yeah,
I think
just
it's
need to return it.
false, but you have to keep it if mark is false.
you could invert basically this statement, right? But says
But
boolean.
like with another.
You need to
symbol.
put parentheses around asterisk and
Right.
x.
Da-da-da-da-da.
No. Sorry, you need to put parentheses.
Yeah,
asterisk,
I got you.
And the not, because we want the other way around.
And the not, which goes before that, but it doesn't seem happy with it.
You cannot
Not
borrow star x. Because it's behind the reference.
And
So
it cannot be borrowed as a mutable.
Consider changing this to be a mutable reference to a mutable reference to a mutable reference to a mutable.
So it's a double reference because filter itself is a reference to our active boards list vector, which itself contains mutable references. And I think what Tommaso was trying to say was, if we dereference the first reference, the one that we got from filter, we should be getting to the original mutable reference. But I don't think that's what it's doing.
No.
And I'm sorry if I lost you on the way.
Filter
okay, the new.
I don't know if you can do that, but let's try.
Must X.
It's still not happy, but maybe I don't need it. No, it's still unhappy here.
Yeah, because it's still giving you a reference to a mutable reference.
Yep.
And we need a mutable reference to a mutable reference, or directly a mutable reference.
Filter map is beautiful.
Filter map was pretty nice.
I think I did spend a little bit of time trying to get rid of this hack, but
yep.
Yeah.
But my question was, why filter map and not filter? You answered my question.
Yes.
Because of
but I think if you look at the type annotation there, it gives you exactly what you want. A single mutable reference to the board. Which filter doesn't give you, because it gives you like that double reference, and the first reference is not mutable.
Yeah.
But why you can't? Please, Luciano.
We maybe can do another step before calling filter.
The outside the reference for having the mute reference. Tommaso, send us a PR. Teach us, please.
Dereference the outside reference for having a mutable reference. Yeah, okay, fair enough.
Tommaso Sensei, please teach us.
Yes. Yeah, we'll commit this, and yeah, if you fancy doing a PR, that would be wonderful because I'm
But
not
it,
fully sure I understand everything. Oh, okay,
yeah,
okay.
it's just a
It's
question. I
just a
don't know, but
question. Fair enough.
to be fair, this is a pattern that keeps showing up in Advent of Code because often you need to filter
Yeah.
out lists of big objects. So you
Hmm.
keep reference to these objects and then you try to filter the list. It's not the first time we find this
Yeah,
particular use case, and every time we get stuck in there. So this time I found this solution which looks a little bit ugly, but it does what it's
yeah.
supposed to do.
It
So
does
I don't
work.
know. It would be nice to find either another solution or maybe abstract this logic into a function that
Yeah,
accepts a closure and gives you back what you want in a more abstracted way.
fair. Well, for now,
So,
I would suggest we commit. Or, sorry, Roberta?
so you were saying some kind of trait to put on top of a iterable that
Or even
give
a
you,
generic function that we can just call to
yeah,
say drain this thing with this function.
that you give an iterable, you give it a function to check all the elements of the iterable. Probably mutable is better because we saw that is useful, and it give you back a new something iterable that you can collect with only the elements that
Hmm.
basically is a filter.
Yeah.
Yeah. Or
I
non.
mean, in the end, the drain is smart because here you are creating a new vector every time with the new references and discarding the old vector of references, right?
Yeah,
I think so,
So you
yes.
are allocating new memory and unallocate memory, and you do that a lot of time. And every time you remove one board, probably, or two boards. So you
Or
allocate
yeah,
like
or even
you
zero, yeah.
or even zero. So you allocate like crazy in this way.
sure.
Drain, I hope, is smarter. It works in place, and it just I don't know. They have a linked list or some kind of stuff that they can just allocate a single cell of memory and keeping everything
Mm.
compact. No idea, but I
It
feel
could be interesting to look at the code at some other
probably
point.
Mm,
this one is allocating way more.
yeah. Well, it reassigns active words on every loop.
Hmm. By the way, one
The
suggestion I have before we commit, it
yeah.
could be to remove the duplication from line 67 to line 73. We could simply create
To
a
break this.
function called parse input that returns a tuple of
Sure.
the sequence and the list of boards. And then we can use the same function in both part one and part two.
Oops. That was my
Ooh.
attempt at writing an
Somebody is doing
ampersand. God.
PHP.
No, I'm not actually.
And
That was
doing
my
this,
attempt at an ampersand very unsuccessfully. So we're returning
We are
what do they want? A
returning
vector
what?
of boards is the second thing.
Hmm.
And the
in
first
the
thing
first,
is just a vector of U64s.
Yeah, which is the number being extracted.
Yeah.
well, sequence is an iterator of U64 in our.
Is it?
If
Where
you
is
look
it?
at line
Gross.
52,
Oh,
Ah,
yeah. So we
fair
will
enough.
need to either collect or we should try to return like a box of a generic trait that implements that iterator.
but then will it require lifetimes?
No, don't think
Okay,
so.
Okay, so hang on. This
well, we
needs to
can
be.
start with a vector. Let's materialize everything. But in the end,
Yeah.
for the sequence, we can just return an iterator.
So you just need to call collect at the end of this
Yep.
thing. And you probably
Um,
need to give it the type on the
specify
left
the
side.
type,
Yeah.
I think. Yeah. We haven't actually
Column,
done this in quite some time.
Column
just do
vector.
vec.
Yeah. Vec of
By the way,
U64.
what if you just give it underscore? Is it gonna be able to infer?
Vec of underscore.
But probably if you try to return it, it can infer from the return type. Try to return seq. No, without the
Yep.
return. Okay, well, as you want.
Oh, yeah. Okay, fair. Yeah. Sorry. Well, now it might actually be able. I don't know if it's going to be able to infer.
Yeah,
Yeah,
it is
did.
able.
It is, yeah.
And why
Why is it
doesn't
not happy
like
though?
that?
Because
Board declared this.
boards is mutable.
Ah, it's mutable here.
Do we?
No way, but this is just a warning. You can remove that. Yeah.
Yeah, we don't need it.
Now it's complaining about
private type board.
Oh yeah, let's just make this function private. Let's remove the public.
Oh yeah, it doesn't need to be public, to be fair.
And now it's complaining that we are not using it, but we'll be using it.
Which is perfectly fine, yeah. So, oops, sorry.
So now you can do a single let of
sequence and boards
or mute boards.
I think both needs to be mutable, yeah.
Yep, because we need to go and mutate
well, sequence, I don't think must be mutable. We are just going over it. We are not.
You are right. Yes,
correct.
Just
yeah.
the second one.
We are removing nothing from sequence.
It seems happy enough. Let's do the same for part 2. Leave the active boards thing on its own, and let's see if the tests still pass. I'll run them one by one.
Cool.
Okay, and test part 2. Yeah, it still works. Lovely. Yeah, that is nice. Nicer.
Okay, now we are returning a vector of sequence of U64 as sequence of number. Can there just return? Can we return
an
just
iterator?
An iterator instead of the vector? Because
yeah, we can.
Why not?
Yeah, so the only tricky bit is not collect. Yeah, is that iterator is a trait, it's not a type.
Yeah.
So we need to return what is called, I think, a trait object, which is kind of saying is going to be something that implements that particular trait. And that something is not something that we know the size of, because it's can be any type of object. So we need to put it into a box. So I think that the actual type is going to be box, then angular brackets, and inside you can say impl and that particular iterator as you see it in line 50.
So the pip iterator.
No, just say impl space box. Sorry, box curly braces. Remove impl.
Sorry, man, I don't know this. Apologies. So box curly braces.
So now curly angular braces.
Angular.
Okay.
Now impl. Sorry, I'm terrible.
You are setting down traps.
Space,
I'm not.
And iterator with upper. Yeah. Now again,
U64 or
item
angular.
equal U64.
They are angular. They are not curly.
They're angular, yeah. I've seen this somewhere before, but I'm not sure if it was with a colon.
Equal. You can see it in line 50. It's the suggestion you get in line 50.
Okay, there we go. That is what it was.
So that should work. I'm not sure if we
and what we do with this that we wrote.
Just put it as a replacement for vec U64 in the return type.
Here.
Okay.
And now remove all of that. And you should be able to remove collect.
Mismatched types. There isn't any collect. Wait.
Oh yeah, you need to box this one. So put box column from in front of sequence. No, not as
in line 56.
Sorry. Oh wait, box from this thing.
And so what is a box?
And now it's not happy with the split ones thing.
Oh yeah, there is another way that we can do din. That's maybe easier. Okay. We'll try that in a second, but basically box is just saying I'm gonna put this value in the stack and provide you a reference. Sorry, not in the stack. Rather than keeping this value in the stack, because I don't know the size, so I cannot put it in the stack, I'm gonna put it in the heap, and I'm gonna become like a smart pointer to that object.
Okay. But now we have to deal with lifetimes.
No, because box is kind of a struct, so it kind of abstracts all the pointers for you.
But well, split once is complaining about something.
Yeah. Sorry.
Then I don't know. Okay, let's see what so Thomas is suggesting, which is basically rather than using box, there is another syntax which I think it does the same thing. with maybe a simple. No, don't remove the impl part. Just remove the
Okay.
box and the angular brackets. And then put in front of impl ampersand din as dynamic, so dyn space. Let's see if that works.
And change the line 56, removing the box.
Yeah, correct.
Is that the right syntax, though? I don't know if that's the right syntax.
Without
Maybe you don't need...
Tommaso say without,
without
the ampersand, yeah.
Okay.
And now he's complaining about...
Do we need to remove impl as well? Maybe yes.
No, it's still unhappy. Prefix of a trait objects type.
Okay, doesn't need again the ampersand in front of din.
Oh my god.
Yeah, that's it.
No, that's not it.
Now what's complaining?
Consider borrowing here. Mismatched types. Oh, because this is a...
For me, it's fine to return the... No, the borrowing with the ampersand.
Yeah, but now...
Fine. Now, lifetimes.
It's not an iterator. It's not implemented for dynamic iterator. Do you know that collect was actually pretty nice?
Yeah, the vector and the collect were beautiful.
Yeah, I think we might be able to do something else with asref iterator, but I don't know.
Now what is complaining about? Iterator is implemented, but not... is implemented if it's mutable. I want to iterate over it. I don't want to mutate it.
Oh, because no, it needs to be mutable now.
Why?
Oh yeah, because an iterator is
it
mutate.
Consumes.
It's keeping track of where it is. So
no, it's not keeping track of where it is. It consumes as you iterate through it, right?
And now it's
You're left with
again.
nothing. It is not an iterator.
Okay, can you just do a dot and see if there is like a dot either? Or
into either.
Into either. Okay, let's try that.
Yeah.
And you need that mutable in line 60. Can you try to remove it? See.
It will complain otherwise. No.
No, because into iterator returns a new iterator of the thing.
Okay.
So, are we allocating less memory like this? I hope so.
There is another error there.
Is there? Where?
Line 77.
Wait.
74.
We need to call into either as well. Yeah.
Sequence. Wait. Fuck off. Sorry.
See, yeah. Sorry. What did you say?
I didn't say anything. Sorry. It must have been the wind.
The wind.
Sorry.
Okay, now it's realizing that there are more errors. I think there was something else.
Okay.
Yeah.
Yeah, I think we might use asref, maybe. I'm not sure.
But the vector of U64, it was beautiful, guys. Yeah.
I think so, because I mean, considering that it's
okay, it's 100 numbers. It's not 1 gigabyte of numbers.
Exactly.
But if it was a huge amount, allocating a vector starting from a string that is already in memory, make no sense.
Sorry,
I use the numbers once, so you just go with it. If it was, for example, again, sorry, if I compare with Python, it will be a generator.
Yep.
Rust has generators? Not yet.
Oh yeah, because I need to collect.
Luciano?
Ish, meaning that you can do it with you can do it with iterators. There is a proposal that should allow you to use yield, but I don't think that's stable yet.
Okay.
So you
can, long story short, you can create generators with iterators. It's just more painful to do when you have complex state.
Yeah, like in Go, you can create generators with channels and Go functions, but it's not exactly the same.
Okay, so it does work with a vector.
There is a suggestion here, that is this one.
What is that guy?
I think that basically means infer the lifetime.
I'm not getting it, sorry.
That plus
Plus
quote underscore
quote, okay.
means this is the type, but also it needs to have a lifetime that you should be able to infer, something like that.
Okay, fair enough.
I can infer the lifetime of the vector.
Okay, let's keep it as it is. It's simpler, and then we can. I mean, if we want to spend more time, we can do a PR later.
Yeah.
Yeah.
I think it's well, definitely more readable now. It's nicer to read, not readable. I don't know if it's gonna perform any better, but we can find out just
But
committing it
when?
and we'll get the results. Should I commit this?
Yes.
Let's just see what we did.
I don't know if you want to stash, run the benchmarks, unstash, and run the benchmarks, but I think the performances will be very,
But
very
we
similar.
will get the differences on the PR comment, right? Or
Yes.
I
Oh.
actually
Yeah. You're right.
No, because there is nothing in main.
does it need to be in main?
Yeah, when you create a pull request, this is comparing the code that you have in the pull request with the code that is already in main.
Okay,
Because you want to know how your pull request is changing the performances of the current committed code.
Cargo
Wait.
bench.
You
No?
need to do it in the folder. So go
Yeah,
into
otherwise it will run the
correct.
cargo bench on everything. And
Okay, year
Is
2021, exercise
04.
04. Yeah, you're right.
Now
We don't want
cargo
to run.
bench.
Did I spell that right? I did. My
while
typing is getting worse.
while it install everything again and compile, have you stashed it or not yet?
I have stashed, yeah.
Okay, sorry, I missed the comment.
No, you're all right. Yeah, I did it quickly. Let's see.
The quickest keyboard of the West.
That's not me, man. I'm the slowest.
That's not me.
I'm the slowest keyboard and the least accurate of them as well. So
of the East.
yeah, of the East. Of North Dublin.
Of North Dublin.
Okay,
part 2 is way slower than part 1. I mean, I understand that finding the last winning one, but they are 100. I was not expecting so much slower.
Yeah, it's like probably because it's allocating all the stuff
probably all the
time.
allocation for all the loops could be.
That's something we could look at. Let's rerun with the changes. So it was
I don't think there will be a lot of change, to be honest.
800 microseconds and 1.2
1 second. Yeah, 1.2 second.
Millisecond. But well, in any case, I'm not expecting big differences. Instead, part 1 is crazy slower.
Oh man, that's
what the fuck we did?
Probably because we are now allocating that initial vector.
Or the chain. Could be the chain, because we are calling the chain a lot of time.
Jesus, they're both a lot slower.
Could it be that chain in the mark? Can we go back to the old mark? Go in the pull request, copy and paste the old mark, and use the old mark.
Oh, the one without the chain? Yeah, sure.
With the one without the chain, because that chain is smelling to me.
Hang on.
Well, now the code is more readable. Twice as slow, but come on, it's readable.
Twice more readable.
Yeah, exactly. It's slow.
Twice the time, twice the readability.
So
more is better.
The old mark function we want. Hang on.
Yeah.
Is this going to copy nicely or is it not? My guess is it's going to.
So the right way is not trying to code at random. The right way will be to have a
profiler, and a flame chart.
Yeah, flame chart or profiler. Just
let's cargo. Oh wait.
There is an error there.
Is there?
Seems to be complaining.
Oh, because this is still U8 because I copied from the.
Okay.
Cargo bench.
I hope the tests are still green because otherwise.
If I have to guess, it's just the allocation of.
Tests have passed.
Of the parsing, but the parsing is doing the parsing only once. Is impacting so much the performances because it's parsing the input? No, it's faster.
It's not that fast, yeah.
Is faster than the chain, not
But
as
it's not.
fast as before.
Mm-hmm.
Hmm.
So this is
So
just
the chain is impacting only 10%.
Well, that is already a big number, in my opinion.
Yeah.
If we want to be honest.
Let's try and see if it was the vector. Come on. So instead of using the parse input thing, we're just going to go away.
Copy from the pull request the old code at the beginning of part 1 and not call the function and just.
Oh
Just
yeah,
copy
let's ignore parse input and also.
Yeah, I can just copy it from there because it's the same code.
But this time you don't need to call collect. Basically.
Wait.
In
Type
line
in it.
65.
Oh yeah.
At the end of remove collect.
That's what
And
we
you
want.
don't need
Ethermut. I do wait.
What? Cannot borrow. Oh, because let's mute words. Because it needs to be mutable.
Okay. Let's just try to
let's just
rerun
try just run the bench again and see if it's actually quicker. It's just going to be part 1 affected.
You changed only part 1. Okay, let's see if it's that.
Yeah, see if, well, if there's an improvement, we can do the second one. If there isn't, it means it's something else.
Does Rust has some integrated profiler, or do you have to use something external? No, part 1 aligned a little bit slower, but
I
have no idea. Something to research.
Yep. Why is it slower? Okay, I'll redo the changes to keep it on the.
Yeah, let's keep it readable, even though we know it's not the most performant.
Yep. Well, it's not. The mark thing, I'll undo this as well because it was like 10%. Not a super big difference.
And we still have the Git history if we want. That's just not squash and merge. That's just merge without squashing, so we can keep the commit.
Tests are still passing, so I think we're good.
Okay, so we can commit like this.
So git status, git white 2020. I'm sorry, I'm not very good at typing.
Make a code slower.
Yeah.
Improve readability. Disimprove performance.
But prettier, yeah.
There.
Nice.
Clear enough. Origin, and I need. Why doesn't this?
Git ranch.
Git ranch, yeah. That's where we grow our repositories. Push origin, this thing. Whoa. Not this thing. Does it? Oh, I need to copy from here. Yeah, okay, there we go. Pushed now.
Okay. Should we wrap up?
Yeah.
Okay, I'm gonna stop sharing then.
Let me do the usual spiel. Thank you everyone for being with us. So we'll continue this next Monday at 6 p.m. Dublin time, which I think is 5 p.m. GMT right now.
Maybe.
And basically we'll continue with exercise number 5 of Advent of Code 2021. And feel free to check out our repository, which I'm gonna show now the link. We accept PR. We are trying to learn Rust. As you can see, we have been stumbling on a number of different issues. So if you know better solutions, feel free to suggest. We just want to learn and get better. And of course, follow and subscribe, because we'll be doing more of this, and any feedback is most welcome. Thank you very much. We are going to do a raid, and let's see who we have to raid. We are going to raid somebody that I think is going to be doing some React full stack Node.js development.
Cool. Enjoy the lack
Bye.
of references. Bye.
Bye.